at that 3.9. So this is definitely stuff that you want to focus on. And Gio's in the house. Gio, you weren't here yesterday, right? Those were pages that were missing from the book. Okay. So we're looking at 3.9 only, the front page. Yes. And I brought some more note cards just in case someone needed 1 or 2 or 12. All right. So on the very front, it says the mean standard deviation of each distribution. So problem number 1 looks like this. We have apples and we have oranges. Okay. They tell us the apples have a mean of 85 and a standard deviation of 12. The oranges have a weight of 100. And this is in grams, and 16 is the standard deviation. So x bar standard deviation. Cool? Or I guess we can make that mu. Means the same thing. So find the mean and standard deviation of each distribution. So A says the total weight of an apple and an orange. So now we're combining it. So we're going to combine the two. So that means to get the new mean, I'm just going to go 85 plus 100. So my new mean is 185. That's the simple one. In order to get the new standard deviation, you need to you're going to do the square root of the sum of the squares of your standard deviations. What did that come out to? $12 squared plus 16 squared root. How much? 20? Oh, okay, cool. All right, so find the mean and standard deviation. The total weight of an apple and an orange. The difference so find the mean and standard deviation of each distribution. The total weight of an apple and orange. Okay, that's A. There's your mean, there's your standard deviation. The difference in weight between an apple and orange. Well, B is apple minus orange. So an apple weighs 85, an orange weighs 100, negative 115 or negative 15. That's all that is asking for. The total weight of 5 apples. Total weight of 5 apples. 5 times 85, which is what? 25, carry 2, 40, 425 grams. Yeah, 425. I'm doing that right? Yeah. All right, D, the total weight of 2 apples and 2 oranges. Okay. So apple times 2, orange times 2. What does that come out to? Boom, 160, 170 plus 200. So 370 grams. It's all, did I do that right? 370. 70. I didn't add 372 for some reason. E, the difference in weight between a bag of 3 apples and a bag of 3 oranges. Oh, okay. So a difference in weight between 3 apples. So 85 times 3 minus 100 times 3. Was that 15, 24, 25 minus 300. 15, 24, 25. What is that? Negative 45, which is just triple of this, which that's what it should have been. All right. Am I doing it the same way we did it yesterday? Yes. We're good? All right. Yeah, that's a change. Okay, so now, then we get to number 2, and it says, create shaded bell curves and calculator commands for each. Okay? So, 1 apple and 1 orange selected. What is the chance that the apple is greater than the orange? Okay, so I can do this. App minus orange equals 0, basically. So they said that the apple is 85, the orange is 100, so you get negative 15. What is the chance that the apple weighs more than the orange? So the apple weighs more than the orange. Okay. So what do you think? What is it?
Do you want the answer?
No, go, what do we do?
Oh, you have to find the new mean, right, and the new standard deviation. So that's 185 and 20. Then you do the normal CDF command.
Normal CDF.
So 85, 100. Then 185 and 20.
185 and what?
20.
Okay, so this is how we plug it into the calculator. So we want to know, what is the chance that it weighs more? Bank very little. So we know that the orange, or the apple weighs this, the orange weighs this. So if you think about what's going on here, you're talking about a region like this. So what's the chance of it happening? If you do normal CDF on the calculator, what did that come out to? 0.001%. So it would have, this would have given an answer of roughly this.
Yeah, when we did it on the calculator, it had the E symbol in it.
Yeah. And if you multiply that times 100, that's where you get this. So what's the chance that your lesser mass object, because the standard deviation sways out a little bit, weighs more? 0.01%. So a very unlikely chance in this case. And you're like, no, I've been to the store, I've seen bigger apples and oranges. I understand. You watch out, you might be getting pig feet put in your shopping cart by Stirrup. So in the recording, that's not going to make sense to the person who's listening to it online going, what's this pig feet in shopping carts? 2 apples are selected. What is the chance that the 2 will have a total weight greater than 200 grams? So the apple weighed, each apple would weigh this, right? And we want to know, how can that become greater than 200? Okay? So what do? We work it. What do? What do we do?
Well, we have to find the new mean and standard deviation for 2 apples.
Okay, so the new mean is 85 plus 85, which is 170. The new standard deviation is?
Will be 12 squared plus 12 squared.
12 squared plus 12 squared.
16.97.
So it comes out to 16.97 is our new standard deviation. I like it. Then what do? So think about it on the normal curve, what we're doing. We want to find a region over here. We want to know greater. Okay? So normal CDF? Or inverse norm. So
normal CDF because we normal CDF because you're trying to find one that's greater than 200 grams.
Cool. All right, and then what's my numbers I put in there for normal CDF?
200, 1,000.
And why am I choosing 1,000?
Because it's a big number.
Yeah, it's further to the right. And then we're going to put it in our new mean and our standard deviation. And what did that come out to when we do that on the calculator?
0.385.
0.385.
So 3.85%.
So 38.5%. Huh. That's where it'll be. I'll be right back. I want to go look at something. All right, let's start kicking around this review. Okay, we'll review today and tomorrow. So if I gave you some normal distribution, and let's say they had this all as rectangles underneath there. And you're like, Sturb, you don't make rectangles really well. I know.
Those are rectangles?
Trying to be. So it's basically we have a histogram that happened to fall into a normal distribution. Let's say that the mean is not given. But we have like, let's go 7, 9, 11, 3, 1, -1. All right. What, if you just by looking at this, and I said, what is our standard deviation? Estimated standard deviation. What do you think you would have to say it would be? If that was all the information I gave you, what do you think it should be? Standard deviation. So we're not at the mean. What's completely obvious to you? One standard deviation. What does it look like one standard deviation would be? How much? 2, yeah. Okay? Basically, these are all counting by 2s, right? Okay, yeah, we don't know the mean, but the mean, it's got to be 5. So we just kind of look at, what's the distance from each iteration? And you just need to kind of go out and you just kind of have to think, okay, how far would this be from here? Okay, even if these didn't have the exact same counting amount, they should though, but even if they didn't, you're looking here, you're saying 3 to 7 is 4, 4 cut in half is 2, because the mean would have to be in between the two. There's a lot of Z-score stuff. So remember, the Z-score is the observed minus the mean over the standard deviation. Please know that we can have the mean be that as well. Okay, and it's not real vital that we have the difference between the two. Just know that they can be interchanged. So you might come across a question saying, hey, you have a Z-score of 20 and you have a mean of, I don't know, 300 and a standard deviation of 10. How would you solve for your observed value? Observed. How would I do this according to this information? What do you think? Yeah. What am I looking for? The observed. This is my unknown. Hey, friends, a lot of you during test, I don't know how to do this. I don't know how to do this. I don't know how to do this. When I look out there, I'm seeing this. While I'm trying to go over stuff. And then you have the gall to say, oh, I don't get this. Let's make a choice. Okay? Please. So, Z-score 20. I don't even know if this one will work out. I'm just made it arbitrary. I'm going to call the observed x minus 300 over 10. Multiply 10. Oh, this will work nicely. How do I, algebra 1, folks, what did I do here? Did I just multiply by 10? Is that just algebra 1? I don't know, I did bad in algebra 1. Don't say it if you're in my class, Ethan. Add 300. X equals 500. So if I had a Z-score of 20, I just, bless you, I just have to go and solve it. Okay? So that's just kind of handing it to you. This equation is given to you, but you just have to know sometimes you are looking for the observed, sometimes you're looking for the Z-score. and it's just a matter of solving it algebraically. 5-number summary. A lot of people miss this on the last test. Why would that represent a good 5-number summary for a normal distribution? Yeah, so 20, 20, 20, 20. That's what you're looking for. A lot of people, I mean, they have like weird ones like 17, 20, 30, let's see, go 40 and 43. So they go like this and they're like, oh, it's got to be this. Well, this goes by 3, this goes by 10, this goes by 10, this goes by 3 as far as the distance between them. So that's not good. So, and then I'm not a fan of this one. This has to do with box and whiskers. And you don't have to remember box and whiskers entirely, other than to know 25% of my data is here, 25% of my data is here, 25% of my data is here, 25% of my data is here. Remember that? So if they were to say, how does this, let's say this would have been a normal distribution as a box and whiskers. So that means, okay, well, let's say we have a normal distribution. So things you know about the normal distribution is 68% of all data fits in between here. If I go a second standard deviation, this is 95% fits there. So if I asked you, how do I find the 75th percentile? Okay, this is where the 75th percentile rests here because 75% of my data is to the left of it. Okay, if you were looking at this, where would 75% would you think fit? And this is the mean, 1 standard deviation, 2 standard deviations, -1, -2, and yes, we could have went out -3, -4, whatever. Where do you feel, just by looking at this, 75% would exist? Would you be okay that if I included this region here? Because that's 68%, right? So now I just need to figure out what I would need to add to it to get to 75%. But I'm not going to add to the right as well. I'm going to take a look at how much area this would really deal. Oh, that's a bad color. I'm sorry. How much area would this really deal with here? Okay. So think about this. If I were to go from here this way, we have 50% of our data. Okay. So that means that this middle region here would be 34% on one side and 34% on the other side. And you're not going to be able to get too exact on it. Okay? You might be able to, but think about this. Oh, I don't know why I put 75th percentile. I'm sorry. If I went out to here, if I was here and I wanted to talk about this region here, let's highlight this. Let's make a nicer stirrup. I don't think I can make this look any better. About how much of your data is going to be in that green shaded region. So with the subtle hints that you have here, if you have 50% going from the mean to the left and 34% to the right, what percent am I looking for as far as that goes? Okay, so So that this green region represents 84% of our data. Okay? So 75th percentile is here. Gosh, we're real close. You know, and the thing is, we can't, if we don't have enough to sit there and start chopping things down more and more and more, I think we have to kind of look at saying that a z-score at the 75th percentile, even though we're 9 away, is pretty darn close to the 84%. I might have went backwards on that problem a little bit, but that's kind of, figuratively what you're looking at. Okay? All right. Let me see if I can make this. Can I make up a problem? This might not be good. Starbucks. Most of us have been at Starbucks. Yep. Yes. So once you order, this is made up information. Once you order your drink, the average time to get it is, let me see, good. How much time does it take to get a drink at Starbucks? I don't know. Once you've ordered, does it really take about 5 minutes? Okay, so let's do 5 minutes. Is 5 minutes. And then standard deviation, let's say it's 2 minutes. Let's stick with 2. Make it simple. Okay, does this seem like it could be kind of real life? I realize that you're going to have the one kid saying, look, I waited for 45 minutes and I had to yell at the manager 3 times. I got kicked out of the store and then they gave me a $20 coupon. I don't know if that happened. All right, so what is the z-score for somebody that waited 8 minutes? So, what equation should we use? Z equals observed minus the mean over the standard deviation. All right. So where am I plugging in? 8 over. So that's 3 over 2. So you get a z-score. You're 1.5 standard deviations above the average. Okay, so does it seem like it could be likely? I mean, 1.5 standard deviations outside is not obscurely crazy, but it's still there. All right. What length of time would the 88th percentile be? What do you think? This is not a z-score one. Agree? This is now a calculator one. Agree? So which calculator function is it? I'm sorry? Yeah, it's the inverse norm. Yeah. So I want you to think about what this is meaning. This is basically meaning I have 88%. This is 88% of our area, which if I'm trying to figure out what this is. So this is going to be your inverse norm. So on the inverse norm, I'm not going to plug 88 in. I'm going to plug what in? Yeah, because this is a percent. I don't want to have it as a percent. I want to have it as a true decimal. So 0.88. What comes next? Yeah, so the mean is 5, the standard deviation is 2. Can someone who has a calculator do that for me? Inverse norm, 0.88, comma 5, comma 2.
7.34.
How much?
7.34.
7.34 minutes. Hey friends, have you at Starbucks waited maybe 7.34 minutes for a drink? I'd say if it's pretty busy. So it's not. So if you start getting numbers like, think about the reality of it. If that came out to like 4,255, do you think you might have made an error? Yeah, I mean, kind of go back and look what the question's asking. Is it really that likely I'm going to get something in the thousands of minutes? If you're waiting thousands of minutes for a drink at any location, I no, that's not good. Yeah.
One of the questions on the review says what Z-score is at the 95th percentile.
Ooh.
You just plug in 0.93 for the observed value.
Uh-huh. And then if you don't know the mean and the standard deviation, what do you have to put in?
0 and 1.
0 for the mean and 1 for the standard deviation. Right. I was just seeing if I had is my attendance right? Swanee to make it?
Can I get a?
Yeah.
Thank you. I didn't know that. That's what. Is it right here?
Oh, yeah, it's right there. I was looking at it before. So what? Let's build on this, and then we'll go back to your question on if that's okay.
Oh, that's fine. You answered my question.
Oh, I did? Yay. All right. So let's say Starbucks will give a free drink for someone waiting 9 minutes. So let's say they have up on the board, and I know they don't, but let's just pretend. Let's say when you go out there and like, what's your name, and you make up whatever name you want to give them, but I would probably just say Chris, and they would spell it Kris, and it's like, okay. But then it would show up on the board Chris, and then there'd be a thing that would start counting. Does that make sense? So Starbucks, because people are getting a little worried, going, I'm waiting too long. So they decide our promotion for this month or this quarter or this whatever is going to be if you wait more than 9 minutes or you wait 9 or more minutes, we'll give you a free drink. Kind of ease the tension of people. So you're in there and you're watching the clock going, come on, baby, go over 9 because you want the free drink, right? Now your time isn't quite as valuable as it had been. All right, so now let me ask you this. How am I going to figure out? What did I say the mean was? 5 and 2. So 5 and 2. So mean and standard deviation. So Starbucks will give a free drink for someone waiting more than 9 minutes. So if we think on a normal curve, you're basically talking about these people over here. Okay? How do you want to do this type of problem? Yeah, I'm looking for this value here. I'm looking for this X value here. So it's normal CDF. I'm going to put 9 in, but then I'm going to put an obscure value that's to the right. Now, I don't have to go to 10 million. I mean, 9 is kind of far out. Could I go to 30 or to 50 or to 100? They're all going to give you about the same value. So you just want to make sure this one was much further out to the right. 100 is way, way out here. Okay? And then I'm going to plug in my mean, my standard deviation. Friends, normal CDF, go for it. What do you get? .022, which equates to 2.2% of the time. So think about this. Now, how would a Starbucks, if they promoted this, what's the most expensive drink you get at Starbucks, roughly? I don't know.
$9.
$9 or $10?
$9 in a drink.
Oh my gosh, okay, cool.
It was like a
Yeah,
sweet
I was gonna say, it depends
Okay.
what you add.
Also,
So a $9 drink.
one of every syrup?
Huh?
How many additives did you do?
Now, let me ask you this. You pay $9 for a drink, but you know that if your drink order takes more than 9 minutes to get to you, you get a free drink. Now notice, is the free drink necessarily your $9 drink? No, you get the coupon going.
It's a grande.
For a small, is the grande the small one?
No.
What's the tall?
Yeah, but they give it to you for a grande.
All right, so they give you a coupon for a tall coffee. You know, if you have $9, how much is a tall?
That's like $2.
Oh,
$3?
$3 is like $3.
$3? Okay. So you spent $9 for a drink. It took longer than 9 minutes. So you get a coupon, and you're like, you kind of feel gypped now, don't you? But so Starbucks at 2.2% of the time, a customer is going to have to wait longer than 9 minutes for a drink. And I'm sorry, I wish I liked Starbucks. I just don't. How I drink my coffee.
I'm gonna go get coffee right now.
Okay. By the way, that drink you gave me the other day, woo! I was walking on sunshine for about an hour afterwards. That was wonderful.
Sugar rush with the caffeine.
Oh yeah, I mean, I was like, chasing bunnies around outside, chasing the geese out of the parking lot. It was awesome.
A caramel mocha.
Yeah, it was
From Zscore.
perfect. I loved it. Thank you. But I don't like Starbucks. When I drink my normal coffee, this has got nothing added to it other than ground up coffee and water. So when I get that at Starbucks, I feel like I'm drinking something that's burnt.
It is burnt.
Oh, is it?
Starbucks they burn their coffee.
Why? So you add all the syrup to it? I can assure you this coffee is pretty dirt cheap too. This was the stuff that was on sale next to the pig's feet at King Soopers.
Their coffee is disgusting.
All right. How are we doing on time? We're almost out of here? All right. Hang on. Let me finish our Starbucks idea because this is going to take us along. I'm trying to follow along a question on the test so you feel comfortable. So we're on a similar type of thing, but not exact. Does that make sense? How about if we said, what percent of people wait less than 4 minutes? What do you think that would be? So if you think about this, if you're talking about a normal curve, you're talking about these people down here. So we're trying to figure out this X value here, this unknown. So what percent of people will wait less than 4 minutes? What should we do? What finds us at X value? Same thing found us the X value here.
0 and 4.
Okay, so 0, so normal CDF. 0 sounds good, or we could go negative number, doesn't matter. 0, 4, mean is 5, standard deviation 2. What's it going to find us? Mr. Peterson. Anybody? 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 Anybody?
Um, 0.30.
0.30. So this would be 30% of our people wait less than 4 minutes. All right, so friends, I will continue with review tomorrow. Let's answer that question tomorrow that you had. But this will help you towards, and we all decided that the test will be on Friday. Is that what we decided?
Sure.
Cool. Get out of here, friends. No, here, friends.